Hello, I'm Rohan, 17BC1053, and this is my DA2. So we are basically doing the QAM modulation for 16-bit. So first, I take the file dc.mp4, then I take the info and using the sound function over here, I take the sound. Now I take the time signal over here and I match it and I get the according amount of time required. That means I'll cut out the extra time with respect to y and I plot the original audio signal which is plotted over here. Now to define the quantized levels, n is 32, a is y, and we take the absolute maximum of a and we take the maximum of first value of a max and we apply quantization a divided by a of max. Then using the following formulas we get the basic quantization and I plot that. Once you see the plot, you see that the plot is very much close, that it is not zoomed in, you cannot understand it properly. So the next step is somehow to broaden it, to zoom in and get the perfect waveform. So the first step over here that I forgot to mention is how I've plotted the quantized signal. We have found the a quan and now we are finding the specific values using find function because all the values together, if it's plotted, it cannot give a proper graph. So we find the specific values, and as you saw, even after that, the values are very close by and it's not properly visible. So the next thing is to zoom in, as I said before. So to zoom in, we are taking specific values, nearby values, and we are zooming and plotting the values. That is T of zoom, Y of zoom. That is for zooming in the original audio signal. As you can see, it's very much spread out. And as you can see down over here, the quantized signal is also spread out. And next we take the data in. For the data in, we convert decimal to binary from k minus 1 to 6. We do that, and after that we take the number of samples per symbol, we set it as 1. Then we define a data in matrix using the reshape function and data symbols in binary to decimal again. Now we yeah so now we take the QAM function, which is used to get the QAM modulation by inputting the data symbols in, which we got from data index matrix, by converting it from binary to decimal. Remember, we first converted it from decimal to binary, then inputting the value of m and setting it as binary. Then data mod g is also done using data symbols in and m. Then we calculate the SNR using the following formula. I show the graphs. Here we have taken the random symbols using the random generator, and here we see the scatter plot, and here we see this 16-bit. The image is not very clear, but it's the how the binary symbol mapping occurs. So this is how we do the binary symbol mapping and the QAM modulation for 16 bits. Thank you.